good afternoon, good evening, depending on where you are. Welcome to today's conversation surrounding how Italy gets their rail done right and what can California learn. We'll do a quick introduction on my end. I'm David Sorrell. I'm a board member with Seamless Bay Area, and when I'm not moonlighting as a board director here over the last 5 years, I have been working in public transit in transportation demand management for 15 years. Unironically, I also work at the San Joaquin Regional Rail Commission, which houses both the Amtrak program as well as ACE. Today we have Adriana Rizzo. They will give an opportunity to introduce themselves, and our guest speaker today, Marco. Take it away.
Hey, thanks. Great. Thanks so much. I'm, as was mentioned, I'm Adriana Rizzo. I'm one of the leaders with Californians for Electric Rail, which is, for those of you who don't know, are a statewide grassroots volunteer-based organization dedicated to removing barriers to electric rail through both statewide legislation, local project advocacy, education, and coalition building. I'd also like to introduce our guest speaker today, Dr. Marco Chitti, who is a fellow in transportation land use at the NYU Marron Institute and is involved with the transit cost projects, which many people here may be familiar with. And we're so excited to have him here today to tell us all about, how Italy has blown us out of the water in terms of modernizing and electrifying their railways. So take it away, Marco.
So hello, everybody, and thanks for having me. And thank you for the presentation. So I will just jump directly into the presentation. I'm going to share my screen.
Go right ahead. So one thing that we would like to kind of flag before you begin, Marco, folks, if you have questions that you would like to kind of address, feel free to use the Q&A portion at the bottom of the screen, and we'll kind of field those at the very end. So without further ado, Marco, take it away.
Okay, so today I'm introducing a bit this. So everything started from a blog post that I wrote a couple of months ago, which was the result of a sort of scoping research that sometimes I do. So on the side of my main research, I do some sort of searching further. And it was because we were there is just an introduction, there is an article is going to appear pretty soon, in a month, it's under proofreading about the planning of high-speed rail in Italy. So from the late 80s and how it happened, how it evolved over time and the politics behind it and stuff, which I co-authored with a professor, Paolo Beria from the Polytechnic of Milan. And the thing is okay, yeah, high-speed rail, there is a ton of literature about it, about around the globe, how it was planned, the different things, Japan, China, France, and every country. But there is really literally not much of how railways, the normal railways, as say, there is not really a difference, but conventional rail is been brought to the state where it is, where we see it nowadays, how we have a modern railway, something that we can call as a modern railway in many European countries, and why we don't have it in Canada, where I live, which is even worse than the United States, but also in large parts of the United States, and even where there is, it's as some a number of flows. So I will just jump in the subject just to so what I try to describe this process that brought the railways at the beginning of the century, the 19th century railway, up to the state of a modern railway nowadays, as the long modernization. So it's a sort of long process. It's an historic process that took more than a century. It's been a continuous process, which essentially starts, we can make it start when the 1905, the national state railways are created, taking up a large chunk of the national network, not all of it, but most of the national network. And after they took a railway that was quite outdated, quite not up to the state already at the time. But by modernizing means that they took a railway and they wanted over time, they brought a railway that was capable of more things. So it's not just like an empty idea of having something modern for the sake of it, but it's like more modern means that the same infrastructure can carry more trains, so it means more people. And so for that, we need like more tracks, we need better signaling, we might need great separation both between rail and other modes. We need remodeling of station, platform extensions. We need faster trains, for example. And if we need faster trains so people can reach their destination faster, we can have like that need to change track geometry. We need to electrify. We need to change the rolling stock. We need to add level boarding to compress dwelling times to safer trains. We need something that is safe, more safe than the cars, and even as safe almost as the plane. And this is again signaling, fire safety upgrades to like critical infrastructures like tunnels or like earthquake proofing. Great separation again, like remove all of the causes of accidents, and also more comfortable travel experience for users, which is like level boarding, better stations, intermodality, and stuff like this, and more stuff like environmental friendly and other like elements that are like not directly connected with the uh, uh, sorry, I was distracted. I pop up. And not directly to user experience, but it's more like on a broad scope of the railway modernization. So, uh, sorry. So that's a bit of a summary. So it's a long process. That was not a continuous one. It's made of the different components of a railway. A railway has a permanent right of way. You have the what's called like they call the permanent way in Britain. You have the structure, the civil structure it runs on. You have the rolling stock. You have the electrification equipment. Eventually, you have a lot of technological elements that altogether represent the railway. So the railway product, the railway service is brought using these elements. So the railway that the Italian National Railways inherited at the beginning of the 20th century were railways that were built in a geography that was pretty rough, like more or less similar to California, with the population centers in the worst possible places to connect them, needing to cross mountain ranges, going through valleys. And so it was very costly, and Italy wasn't particularly developed countries at the beginning. And so didn't really have the means to build a lot of this. It was a tremendous effort at the time. But it was an effort that resulted at the beginning of the century with a very small section of the network being double tracked. And for example, a lot of rail with a very high grades, so very steep ones. So it was difficult. This limited like the length of trains. There are also like issues with bridges and clearances. So the trains were like couldn't be very heavy. So it limited the amount of freight that could be transported and the length of trains. So a lot of like technical issues that had an impact in the capacity of delivering the service, the mobility good that the railways were supposed to deliver for a country that was starting to like industrialize, really taking off industrially at the end of 19th, beginning of the 20th century. So in the next years, so what was this? So the intervention was really an ample like dimension, let's say. So every single aspect was targeted in different points with different emphasis over time. One was we need more tracks, we need double tracking, and even the existing railway is not the best place to double track. So in a very rugged context of the, for example, the Ligurian coast. So you had the original railway built in the 80s, 70s, already very difficult with a lot of tunnels and cliff, but in a very unstable terrain, needed to be moved completely sometimes. So to build a second track, but just rebuilding a new railway alongside it, a straighter one, lower grades, longer tunnels, so a pretty quite a long, essentially it was rebuilding entirely section of the railway. That's one of the most typical example. So it's pretty visible in this image from just the post-war year. But if you like look at this, and if you look at like how infrastructure capacity means double and quad tracking, and also alignment geometry was changed, so the two were combined together often in similar projects. So we can look at a number of figures of transformation that has been applied over time that ended up developing really a language of planning that you see in documents wherever. So are we double tracking in sede or in affiancamento, which means just a track alongside the existing track wherever there is room? Or are we double tracking by putting the new railway in a new alignment? So raddoppio invariante, quadruplicamento invariante. Are we just changing the existing line because it goes, as you have the same problem in Southern California? It's a very an area prone to flooding or like landslides, so you need to realign the track to like make them more permanent and less subject to this kind of disruption. So this, a lot of this stuff that were done over time, so this is like the age where it was done. You have like 1 century and like 120 years of continuous efforts throughout the peninsula, throughout the this is like the what is called the trunk network for the classification of internal classification of the railway, which is like the one where there is more traffic, long distance traffic in particular, not just regional one. So I just want to like look at a few things. So some were like very shiny projects, like needed a new line where there was a very steep line, curvy line from the 1890s, 1880s. So the Direttissimi is a sort of like proto high-speed rail. We can consider them the crown jewel of the modernization. It's like big effort started at the beginning of 1900, took 20, 30 years because of the wars to complete. But then there was a second generation who was like the next step before the true high-speed rail, as we consider it as modern high-speed rail planned in the 60s and delivered from the 70s to the 90s. And that's like, like it's not like there is a normal railway and high-speed rail. It's just a rail which has all the characteristic to allow trains to go very fast. And so you get up to this over time. And this are, for example, the example, and it's also where they need more capacity because this is the spine of the country where there's a lot of demand. But also these are modern rail because we can see how they were built. It's a matter of operation before everything. So this is the Bologna-Firenze Direttissima, which it's interesting the way it was built because the easiest way, so before it was built, the train reversed at Bologna Centrale and they took the single track Porrettana line, which was like going up very steep and down. It took like 2 hours to go from Bologna to Firenze, even after electrification. 2 hours before 3 hours. But then they built a very flat line with a low gradients, a lot of tunnels, a very long tunnel to cross the main mountain range, but even a secondary tunnel because they didn't want to reverse Bologna. So the idea was already for operations that is really a modern operation where you have seamless trains, fast trains, express trains that go from Milan, from Turin, non-stop to Rome, and then people can go directly within the day and come back. Not that at the time, but this is something that prepared the time for having like a 3-4 hour travel time compared to the 7, 8, 9 travel time. So you don't need to reverse. You can have direct trains, seamless connection, but you need another tunnel. So you build this tunnel in this place. So, but there are like also projects that are more like taking an existing line and bit and pieces modernizing it through where the alignment is good enough to just lay a second track alongside it, maybe replacing the bridges that were just allowing 15-ton trains, replace for bridges that allows 22.5 tons, which is the next. There are like a number of classification from the international UEC, Union Internationale des Chemins de Fer, like it's International Railway Union, the association, which are like categories. So that's the highest one that allows like the heaviest freight trains. But in some places you need to build like a bypass, like a cutoff, as I say in North America, or you can build like a partial realignment. So for example, also like this was delivered like this 300 kilometers of the Ferrovia Tirrenica Meridionale were delivered through as part of two multi-year plan, the 5-year plan of 58 and the 10-year plan of 63, 72. And you already see how there was a learning curve. So the first bridge that you see on top, it's already a bridge that was built. The old bridge is a brick arched bridge that is outside of the picture that already replaced in 1928 a steel truss bridge that was from 1870s, 80s, which didn't allow very heavy trains. So it's like already a third generation of infrastructure. And this was built as an arch concrete bridge, which was a design straight out from the 40s, 50s, already used in other projects. So there is a twin bridge elsewhere in Liguria. But then you're already in the second round, you see that this new section which is built for higher speed, which is this sort of cutoff in violet, finished in the early 70s, you already see the pre-stressed concrete bridges that are brought up. So it's a new type of bridge, and this type of bridge you see like sort of improved over time, a slightly modernized version, but it's more or less the typical viaduct you see in the Direttissima Roma Firenze, you see in new, like in Bologna Verona, in many new lines that are built in the following years, and in the high-speed rail built for 300 kilometers an hour. So electrification. So this line was also electrified in the 30s, but then electrification was really something. There was like 20 years in the beginning of let's try everything, third rail, different standards, let's experiment. But then at a certain point in the 1920s, say, okay, we'll settle as a national standard for the kilowatt DC. And it's adopted the national standard. And then there is a continuous effort of like electrifying. There is the big jump in the 30s because of like of the international sanction, because Italy aggressed Ethiopia under the fascist regime. But then this thing like slowed down because of the war, but then it continued. And by the 60s, you had all the main network electrified, and then it's like the secondary network and then the local network that has been electrified. So essentially over time, there are like now it's around 72% of the network which is electrified, and it will be around 80 in a couple of years because of the last funding in the 2022-2026. But the idea is really with so much, and I will go back to this, you have time to perfection the way you are doing. And you have like so 3 generations of technology for electrification that has been developed and refined over time. But you also need to improve, for example, the big urban nodes. So around cities is where you have the most traffic. You have the local traffic because you want commuters to use the train to get in the city, and you want to have this train to stop very frequently, as we call regional rail or suburban trains. But you also have long distance trains because these are one of the main destinations. You might have a lot of freight train because the factories are around here, even if not so much nowadays, and with intermodal. And then you have like a superposition. Maybe if you have a big port like in Southern California, like a Long Beach, you have a lot of freight going to the port. But like at the beginning, it was just 2 tracks where everything was merging, like some of the most important lines in the country, connecting to what is the economic center of Italy. And this was going through the city. And at the beginning, like right after nationalization, the year after, they approved a big plan of remodeling the entire node, which took like 20 years to implement. There was a World War I in between and all the crises after that. But like we passed from like 2 tracks to having 4 tracks, specialized itineraries, as they are called in Italy, for freight. So freight does not get in the way of passenger rail because freight moving between yards is really a mess. We see it in Montreal that is kind of messing up all our commuter rail system because they are really incompatible with other stuff. So it's really, you separate it, you give each line that goes into the node its own track, or almost, and then over time in the 60s, 2 more tracks are added in some areas, a bypass, a new station, and then another track, some great separation here and there, and other quad tracking in the nodes that comes to the city, and then the cross-city rail link, the Passante called. So it's like an underground rail for suburban trains. And so it's not only the tracks, it's also the approaching tracks that are separated as much as possible, because you want to have all suburban trains that comes at like 10, 12 per hours on a track to be on their own track with a lot of stations. And then you want regional express, long distance trains to go on other tracks because near the city they more or less move. And then you want freight maybe to go on another track. So there are a number of issues. There are still like bottlenecks in the nodes, especially for the bad choice that was of having this like stub end station, monumental, gigantic, with a lot of tracks, but it's not really adapted to modern operations. But that was an effort that was carried on in several iterations. In the 30s, in the 50s, Lambrate station was remodeled 3-4 times. And talking about station, it's also like it's a key component, and it's where the interface, where the people like enter the railway. And like this is like I've just taken one example of a station of a mid-sized city, 100,000 inhabitants. That's the typical Italian station of the beginning of the century in a small city. Small building, a little canopy. You have a track with a second platform on the left for boarding. The platform is just like 20 centimeters above the track, 30 centimeters, or sometimes nothing. And you have a lot of like freight going around. Already like in the 20s with double tracking on some lines and the big modernization effort in between the two wars, a new building, larger building, more canopy, and so on. But still, most of them didn't have like underpasses, just the main station. So people just still crossed because there were a lot of people hanging around in the station, and like was called a station chief that was like controlling traffic and everything. But over time, now the same station, so the main building is the same. The old building is in the background here. And this is the picture from 20 years ago, let's say, to now 15 maybe. Like you have like universal accessibility requirements, the canopy from after the war rebuilt. And then you have like an underpass that builds under war so people don't cross the tracks. So train not stopping can just go through the station at 120 or 150 kilometers per hour. The regulation allows this. And if you look at some elements like this little flashes, you can see, for example, this is the second generation of electrification, these rounded poles and this design. And then this is a more recent picture, like, okay, what you see in this, okay, new elevators, larger ones that more conform to the new norm. You have like the platform raised to the 55 centimeter standard, which is level boarding for regional trains. And then you have the new what is called standardized Palo LS, like a local line mast. And then you have the new design, which is an evolution of the same. I will go through it again. And then you have, for example, a better integration with the urban environment with a secondary access, park and ride, because, like everywhere is parking and ride is a sort of myth, also very hard to die in Italy. And at the same time, you have an innovation that it needs to go. So this is not the ideal path, for example, for modernization, but was the one taken by a lot of continental European countries, which is like finding level boarding halfway between raising the platform and lowering the deck of the train, which is good for everything regional up to 20 kilometers per hour. We have a few models that allow this kind of boarding at higher speed, but for intercity trains, you still have steps, which is not like self-boarding and universal accessibility. It's a compromise, but it's been because the network is interoperated on a continental level, so you can't really. It's very hard to coordinate, like having the same level of platform for everybody. So but like these kind of choices that you need to do at a certain point, and this somehow they come on you by path dependency and other problems. So for example, isolated lines in Italy opted for this model, which is more common in North America, for example, in the Northeast corridor, or in some parts also in California, I think, or I'm not sure. In California is more like lower platform. Grade separation. So grade separation is one of the big things. So railways don't mix up very well with other things. They are big, huge, and if they crash onto something, they probably, as we see with Brightline, as has been creating a lot of accident because it's in a very urbanized area with a lot of level crossing. This is the case in Italy too. So the railway used to have several like crossing every kilometer. This is a stretch of some 35, 40 kilometers of the Adriatic line between Bologna and Imola. And the 40s, it was like just great separation happening in the 10, 20s and 30s, just in very dense urban areas with new bridges built over the tracks because it was like the traffic in cities was growing, tramways and stuff. So they wanted to grade separate. But after it was just done in a bunch of places, some local were closed, but the effort in the next 30, 40 years was most about like automating barriers and doing this kind of stuff that has been done also in the North America, like what four quadrants and stuff like this. But then there was a big push. There was a deliberate push with a law saying we are putting a bunch of billions to grade separate the most important lines following a sort of master plan with priorities outlined by the National Railways, saying we are going to grade separate a lot of thing. And so you say like from 78, where the line was still mostly a lot of grade crossing apart from the two main cities. In 2008, there is no grade crossing left. So it means that the maximum speed of the line can be raised from 160 to 200 kilometers, first 180, and then after a bunch of bridges were replaced, to 200 kilometers per hour. So that's gaining minutes with the same infrastructure, with some improvement, and also like favoring like local traffic, which is not necessarily bad, because this is a very busy line that could go up to 10, 12 trains per hour per direction, which is like means like the downtime of barriers is very high. So that means also that, you know, like to grade separate, you need to build structures. Either you close outright, this was one of the strategy. You close for cars, you just keep a small pedestrian passage. You close it, you just say, go to the one like very lightly used here or there, you close it and you say, go east or west, and you cross in another way. But you need to build underpasses or overpasses. So that's when, exactly at this time, there is an entire industry of box checking and a few techniques that have become now, because they have been used for the first time or in the most outstanding way in a city. There is the Verona model, there is the Milan model, there are like a bunch of things that some of these companies, Petrucco is interesting because they operated also in North America. They've done a bunch of projects also in North America, and they have become very niche, hyper specialized contractors. They were like they were born like in the beginning of the 20th century as a general contractor, but they now over specialized in box checking for roads and for rail, because at the same time it's the same thing, so they look for more market. But they do, and they are very much specialized. They have all the equipment, they have all the capacity of also doing research and improving the way they are doing this kind of thing. So we don't, it's a way to building the industry, because when you have reduced the amount of your grade crossing from 15,000 in the 70s to 4,000 nowadays, it means that every year you're doing dozens, if not hundreds, of this kind of thing, bridges, underpasses, and other stuff. So it's kind of established a sort of like pipeline of projects that allows this sort of very specialized contractors to thrive, exist, and you know, like keep working. Or, for example, you can have a lot. This is one of the big players. There are a lot of like second order or third order players, which is this one is also like active international. It's the GCF, but it's, you know, like they can have the equipment, so they can have like they know there will be contract to renovate the tracks, because the main national operator has 17,000 kilometers of tracks. The other like regional operators come up with 4,000 more, but they use the same standard of the national operator. So, you know, like you're just using the UEC RFE 60 tracks with the kind of sleepers that you're using. The mix of concrete is established. You have a lot of things that are fixed, and there are a lot of things that are like standardized over time. So the workflow is much seamless. There are not like different standards that comes up from everyone. And so they can also rentabilize this kind of equipment. They can have this, and they can have this sort of like train, like factory train, which costs a fortune. But if you have a stream of contracts, it's worth the investment. And this, like going back to electrification, this is the interesting thing. For example, if you look, this is like how electrification in 3 kV DC. So there was a different standard for a while. They did also three-phase and so on. But when sort of fixed in the 30s, they say this is the national standard. This was the design from the 30s with some tweaks or there until the 60s. For the first big wave of you have like a mast, which is a tubular mast with this suspended cantilevered cantilever, and then you have this design with the isolators up and down. Then the one in the 70s, there are like innovation about the material is used, like stainless steel becomes a thing, and then it's used, and then a bunch of changes in how the isolator is done. But then, you know, like the isolator is pretty similar from the first to the second, but the design is sort of like streamlined but similar. And then the third generation, which is like from the last 10, 15 years, it's really going with aluminum, much lighter thing. The design is slightly improved to reduce the amount of downtime. It's better for like the expected increase in heat in the future. So, you know, like it's not like inventing a thing from zero, like a space rocket. It's just 100 years of improving over a design that's been pretty effective. The industry knows how to do it. The industry knows all the different components, and also can be exported. Britain is like this last design now has been like used in Britain for 25 kV. It's slightly different in terms of where the isolator is. But, you know, like this kind of stuff you can do if you're doing a lot. And it's the mast is standardized. There have been 2 generations of masts. The foundation of the mast is standardized, but also something, because I remember some stories about California. Where do you put all the cables? The modern railways have a lot of cables for telecommunications, signaling, feeder cables, and stuff like that. You need to put them somewhere, and you want to access them very quickly every time you need them, but you don't want people to tamper around because it can be dangerous or so. So when they built the Direttissima in the 70s, they started to build this extruded like canals to put like ducts. But then it evolved in standardized design, which now it's a standardized RFE design. And one of the dozens of manufacturers that like produce this is prefabricated concrete elements. You have like pages and pages of design because yes, one of the problems is going around the poles. You know, like there's a conflict on the side of the track. You need the poles and you need this thing, but you know, like it's a pretty simple conflict to manage if you have a number of typologies of solving it, and then you have the different elements. So you have the 5 elements that represent the straight, curving right, curving left, and so on. They can be assembled. And then you have the one for high-speed rail, the one for everything above 20 kilometers hour, and everything below 20 kilometers hour. So that's, for example, something that allows to have, when you apply, you have a standard, you just refer, like your procurement is, we are procuring 5 kilometers of this with this characteristic, and it's the model RFE 170, whatever is the number, or it can be TAV RMNA, or is the Unifair Uni 4065, you know, like this kind of stuff. And every element of the railway can be sort of like, the railway is a complex system, but it can be like decomposed in simpler system, and the interface between the system, the more you do, the more you are able to not have problems at the interface of these different systems. But also you can have big manuals and big manuals. So I was trying to scroll. I don't know if it's like a bit of a hectic, you know, like a big manuals with a lot of stuff, you know, like the distance with everything. How do you build trenches? How do you build the drainage, the distance between tracks, and the, you know, like it's not everything needs to be reinvented. A rail is like 2 tracks, 3 tracks, 4 tracks. Yes, there are particular solutions, but it's always the same problems. The problem of settlements on embankments and where they are put to bridge or stuff like this. It's always problem that can be solved. So I'm gonna go. Wait. Okay, so how was all this funded? How this came about? So let's say that the idea has always been since the beginning that the FS should be self-sufficient in terms of OpEx, but CapEx, everything that is like was called like the extraordinary side of the budget, so should be funded by the government through dedicated bills. That's since the very beginning of nationalization. Even though the railway had a pretty big running deficit in the 70s, 80s, and 90s. Now it's not anymore, but it was like for a number of reasons of like changes in public and rigidities and the bad politics of 1970s and 80s Italy. But like for the most of the post-war years, there were like a number of plans. The 5-year plan in 58, 10-year plan. That's all like Lowe's funding a plan. So FS coming up with a plan saying, I need this for this year. It was negotiated, of course, with the government and the Ministry of Public Works, and say, okay, how much can you allocate in the budget? Okay, so much for the next years. This is the list of the projects that we're doing. And then like with yearly updates to the parliament, and then some specific laws for some targeted things like the Direttissima Roma Firenze, the level crossing removal plan, or other stuff. But then this also was like thought too cumbersome, especially in the 80s, which were a difficult period in Italy of spending and corruption and a lot of things going on politically. Sort of in the 90s, which was an era of a lot of reforms in Italy regarding public works and procurement, there was like, okay, we need a more stable framework. We need a more clear framework, which is what's called the contratto di programma, which is a framework contract. Essentially, it's been updated several times, but since 1991, it's a sort of 3-4 year long framework contract. Now it's divided in one part is focused on maintenance, ordinary maintenance, so upkeep of the infrastructure, like state of good repair, and targeted improvement. Like, oh, we have the old kind of mass that is reaching the end of life. We want the new kind of electrification to be replaced. Oh, we have this problem. No, it's like more, how do we keep the up to date, the existing infrastructure? The other one is like bigger investment. We need a new alignment here. We need a bypass here. We need a new line. We need great separation, great separated junction, or everything that is more like on the investment side. So it's a 4 year amended each year. So that's, I will go pretty fast on this. So there is a sort of 5 year strategic document. It's not as detailed, as not as service oriented or like based on a sort of strategic timetable. It's more like based on level of service and capacity of different lines. So Italy has been a bit averse. They're reaching this level of like planning first the timetable and then thinking, especially regional government has been much better at this for regional services, but also because like it's an open access system, you cannot really pre-plan the level of market rate, long distance traffic. You need to create extra capacity to allow for competition. But you know, like there is a process where regions jump in to say, "Wow, I have this. Like I'm Lombardy. I want to improve capacity in the node of Milan because I want to run more regional services. Are you going to fund me this great separation, dear government? Okay, let's discuss about it." They go through committees and stuff. You know, like it's pretty complicated, and then there is an approval process. And then there is a yearly amendment depending on the budget, because governments, you know, can have like more or less will to fund, more or less latitude in the capacity of the budget. And then RFE translates it in a business plan, which is like updated yearly after all this process, which is this is what we're gonna do. And then there are like specific, the plan is like a list of projects, a list of benefits and measurable goals and stuff divided by region and type of service, like regional freight, long distance, and so on. And then it's also there are like multi-year plans, like a station upgrade and accessibility plan that runs through the 2030s. And there is like the first 5 years, this is the target is 50 station of this category, 30 station of this category. And so they have like a bunch of criteria to sort through, or like great separation for the next year. And now you can even see online all the thing. It's like they've done a pretty nice to navigate thing. But that's like the thing is really there's been a constant flow of funds, but they have been up and down depending on national priority. So the big effort of building the high-speed rail, which was like some 35 billion, the main spine, over like multiple years, like from like late 90s until the 2013 somehow. But you know, like then there was like the crisis and so on. So there was a period of like compressing budgets to the point it was just like upkeeping of the infrastructure, not much more built, some stuff, but you know, like it's, and then progressive recovery during the late 2010. And then there is the current boom, which is like, this was the planned thing. And when I did this in 2023, now they sort of realized that they need to spread this out, because even if the you know, like RFE, which is engineering arm, Italfer, they're pretty good at having shovel ready. It's not really a good expression, but you know, like at delivering and following projects, they were biting more than were they able to chew. It's not easy to jump from 6 billion per year in spending to 11 to 16. This was absolutely unrealistic. And now they are more in the 9-10 spread over a longer period, which is a saner way of dealing with things. But these are political priority. Was the European Union pushing for everything? Like the recovery plan need to be spent by 2026. So which lesson for California? So I think it's like, I know that this is like a very hard pill, but nationalization was a key element for Italy and many other countries. So having something where a single actor is in control of the infrastructure, of the planning, of the relationship with the government, of procurement, of every aspect. So railway is a complex system, very complex one. So this level of coordination is very necessary, and that's a reason why a lot of countries are sort of evolved. Like every country with large railway network, like good ones, have state railways. So is it possible to deliver it through a different framework? I don't know. That's a big question for North America, and I really don't have an answer. But the modernization effort was an ongoing and never-ending process. Like the technology evolves. Signaling has gone through several iterations from semaphores to ECTS, ERTMS, or CBTS, or all the kind of different system, or positive train controls and all this stuff. So, you evolve. Like catenaries, yes, same thing. And railways needs a lot of upfront capital investment and need to be planned very much in advance to deliver something that will come 3, 4, 5, 10, 15 years down the line. So it's really the quintessential places where planning is important. So organization, like standardizing, all these things that you see, like design guidelines, reference prices, established ways of procuring some elements. It's all things that were not like invented one day. Someone had the genius idea of how to structure all the system completely. It was an iteration of, oh, this thing is not really working. How do we procure the permanent way? Okay, the permanent way, we take it out of the contract and we just purchase separately all the tracks because we are just a big purchaser. So we do a 4 billion 10-year contract with a steel manufacturer that will like sell us kilometers and kilometers of tracks over time. So of rails, sorry. So it's important. This continuity is important to build capacity within the public actor, planning, procurement, delivery, standardizing, having an up unit that is only task is just to revise and keep up the standards of design for everything, embankments, viaducts, tunnels, and stuff like this. And the sector, like the universities that need to form the new people, and the industry, like the skilled workers, the managers, the companies, the everybody. Like it's a collective effort. There's a sort of collective intelligence that needs to be built up in this supply chain, from the one who decides to the one who execute the last screw. So, and the fact of having like multi-year program that creates the idea in the sector that there will be a flow of work, there will be things coming up, there will be new projects. So we want to invest in research to be upfront, to be the ones that deliver the best cantilever for electrification. Want to be the ones to bring up the innovation. We can invest on this. It's worth investing in research and development. This is really important for our supply chain to develop and to like become strong over time, to the point that you can even export expertise, as Italy does, as France does, and Germany does, and Spain does, and so on, which, for example, England does not a lot. Much less than other countries, for example. So that's really because when you're a champion at home, you can really go abroad and say, okay, look, I have a lot of experience. That's what I learned from my experience. So, and then I will stop here with a picture of the bike path that is on the old alignment of a Bologna-Verona railway line. It was built, you see it on the side, in the 90s, was rebuilt on a viaduct because this is a flood-prone area. And I'll leave you with this because it's, it's many years, a lot of effort. And instead of rail to trail, it's better to have like trail adjacent to rail whenever it makes sense. So I'm now open for questions, and thank you very much for listening. I just went beyond my time. Sorry.
No, this is wonderful. Thank you, Marco, so much for this explanation. I'll knock these out one at a time. We'll start with Max's question. The first one is, the federal government here in the US funds railroad grade separations, what seems to be consistently a few $billion annually, yet we haven't developed this knowledge to be able to standardize the grade separations. In fact, we've gone backwards by vertically deflecting the roadway rather than the railway itself. Is there something that the US federal government can do to help make these dollars be spent better, or to create the market of contractors that can do it?
Yeah, I think it's very important that you build the capacity. Like grade separation is something that can be replicated. For example, in there was this problem. Like grade separation can be done very cheaply or very expensively, depending on what are the standards that you apply. Like if you want a lot of clearances and like it depends really. And whenever the design is done locally, like the federal government throw money, then you apply for a grant. Then there is a local agency that delivers the project, or like a local railway. That a lot of different bodies. Not in Italy, it's always Italfer that does the, which is like the engineering branch of RFE, and so they like they have developed a standard way of doing stuff, and there is also sort of standard cost. So whenever the cost in the 90s, when they were doing like the second phase, they were like, oh yes, let's say that like we at the end of the day, it's just a road going up and down, or a bike path and so on. So just develop a bunch of sort of reference cost, which is like in the very beginning. If your thing is costing double what we expect, your project will go under bigger scrutiny. So the thing is really having some sort of references, or having like the federal government being, what is the ideal design? Or I fund up to this level of design. You want to put more money, local jurisdiction, whatever. I think this is good. If you want to have something that is more gold plated, or like more advanced, you pay for it. So because the problem is that when the person, the entity who pays, is not the one responsible of making decision, there is a lot of disconnect in between how choices are made, because it's really the right hand doesn't know what the left hand is doing. And that's, I think, is what some of the like grant based project with a lot of like scattered center of decision.
Great, thank you. I think we have our next question from Anthony, which is, in the Italian system, how are local to concerns, e.g., where the rail will run, who will it serve, and its impacts on neighbors, heard and decided on? Are locals invited to review and comment on national plans, or allowed to request changes to projects once they're approaching construction? Giving up local control seems like our main hurdle to good transit projects.
It depends what you mean for local control. So there is Italy, so that's evolved over time, but there's been a lot of pushback for a lot of projects. A lot of projects have been canceled, or like completely pushed back by 10, 20 years because of this concern, like third tracking and stuff. And so there is a lot. Italy tends to have higher cost than other countries. One, because the country is more urbanized, it's more like also like more the topography is different, but also because there's been a lot of NIMBYism, and to like go beyond this, they try to do like compensatory projects and buy local consensus. And it's almost normally it's organized, like the for example, like for the Turin-Lyon high-speed line, there's been a lot of pushback, and the project has been like delayed by a decade. Normally there is, now the thing is that since like 5-10 years, there is what is called public debate, which is sort of modeled after the French débat public, which is a sort of thing that says, the French do it better, I think, but it's like, okay, this is the first, like there's like a early stage where they say, okay, we want to have better service here, so these are the options. What do we do? Okay, so then I have more institutional discussion with local jurisdiction, the regions, the municipalities, the provinces when they existed, and like there is like requests. Oh no, I want this tunnel it. Oh no, I want like more noise barriers. I want all the stuff. I want mitigations and stuff like this. And then what they come up is a compromise. Like politics is politics, and this is the kind of thing. I think that the mediated way of doing politics in Italy, or at least in some context, means that at the end of the day, there would be some politician taking responsibility for saying yes or no. Things have derailed in some cases, like in Turin-Lyon, or in some case now, like there is the plan for quad tracking the Adriatic line between Bologna and Castel Bolognese will go through cities, and there's been a lot of backlash from local municipalities and stuff like this, and we don't know yet where it's going, and costs are going up. But I think it's like it's not a sort of like tyrannical government deciding things and going on. There is a lot of thing, but I think it's, parties, there is a sort of understanding that these infrastructures are needed, at least most people sort of agree, and so things go forward. So, like the national parliament support it, there is funding for it, and there are accommodations that are made through the process of participation, that is through this like débat public, like public debate thing. And yeah, but it's there's nothing equivalent or as cumbersome or as long as the environmental review process that you have in California, for example. It's much less like, oh, everybody's come in and everybody says everything, and we just do meetings after meetings after meetings.
So I think combination of two questions here is like, could you speak more about how Italy got this done in terms of like obtaining funding, handling homeowners, landowners throughout the routes? Did it retain like that expertise with projects? And if so, like looping in like mega projects, we're subject here in California to the concept of joint powers authority. So it's a combination of governments or entities that doles out money to actually do the funding. Can you be able to speak a little bit about like targeted funding and like how Italy was able to pull that off?
So, I mean, for the railways, it's a bit simpler in Italy in the sense that for the national network, then there are a bunch of regional ones, but even those are converging or are handling projects to the national manager because they know how to do stuff. They are the ones doing everything. So, like when you have this huge network and a lot of projects and a stream, you can really specialize a lot of expertise. Have RFE as thousand of employees. Some are maintenance people, but some are planners and people in design and stuff. They have their like engineering arm, which is RFE, and they have a legal department, which the entire one of the tasks could be just going through the land acquisition process. And there is an established land acquisition process. There have been like number of reforms of the expropriation law, which says how is like fair compensation established? How is this negotiated? So like there is and it's for everything. It's not just the rail. Every like public work of public utility. Whenever something is like declared of a public utility, it undergoes a procedure where it says, okay, this is the land we need. Like preliminary project. This is the land we will need. We'll publish this list of land with the owner. Owner have 60 days to say, oh, why are you doing this? I want more comments. I want more detail. Then you will need feedbacks, and then you will need like a pre estimates, which is based on tables and analysis of prices that are like it's complicated, but it's like sort of public way. And then people can say, do you accept this offer based on this? No. Okay, there can be some incentive between 10 to, like I don't want to go into the details, but it's a pretty established process. There might be some hurdle, but it's something that where you need to start, and you don't have this problem like, oh, I'm starting to contracting out and I haven't finished land acquisition, because the law is pretty clear about the procedure to having this. So I guess that in California, you'd need, if one of the problem is land acquisition, you'll need to reform the process of land acquisition. I know it's not very easy because there will be like litigations, and it's a fundamental right, like property. But this is something, for example, or permitting. So, for example, you don't need local permitting for railway. The government approve, and it's approved. It goes through because it's approved by a joint committee of the national government and the state region conference. So there is a lot of like, let's decide everything before, but once the final design is approved by RFE, RFE has the power of absolute authority of mandating whatever is going to happen in terms of land acquisition and everything else. They don't need permitting from local jurisdictions, for example. So that's something that helps a lot.
I think, there's still a few questions left, but I would just like to hop in with a few announcements before, we wrap before we hit the top of the hour. Um, once again, just want to thank Dr. Chitti again for his excellent presentation. In terms of, and one of the big takeaways for me is, is that there obviously there's a lot he covered today, but is having this, fairly consistent funding for projects that are that are part of this long modernization plan. We have, I think it was about like 3 to 6 billion euros per year for the last, couple decades or so. And that is a big missing link here in California. California for Electric Rail, put out a statement recently basically calling for California to move towards something like that, where we're providing certain level of guaranteed funding for the state rail plan, which is kind of California's equivalent to some of these the plans that Marco talked about, and that, that planning be that money be incentivized for projects that are shovel ready, that have completed design, and kind of separating out the funding for design um and for engineering. And so I can post a link to kind of that statement on that in the chat. Second thing I wanted to plug is that one way, if you're curious about getting more involved and want to help bring some of these forums to California, one of the best things you can do is join Californians for Electric Rail. I will also post a link to our email to join our email list in the chat. And then the third thing is that, on a much more specific issue, is that, as Marco was just saying, we have this very long engagement processes, which is not ideal in many ways, but it is a chance for rail electrification advocates to engage. So, they are currently planning, this multi-billion-dollar tunnel project in Del Mar, in San Diego County, for the Surfliner, which is the second most ridden train in the United States. And we need people to comment in to ask that the tunnel designs accommodate electrification and to choose the highest speed routes. So I will post all of that info in the chat, and if there's anything that any Seamless or anybody else here wants to plug, go ahead, take it away.
Thank you, Adriana. One of the things that we're following here on the Seamless front is that we're in the process of trying to secure funds for both operations funding throughout the state, which is critical on top of the infrastructure changes and improvements that we need to make, but also set the ground up running for a possible 2026 ballot measure, which should be funding a lot more than just the standard baseline of service. So we invite you all that if you have any questions, or if you want to be able to partake in local matters, at least on the northern half of the state, feel free to join us at seamlessbayarea.org. I'm pretty sure that we'll have another event down the line to talk about transit priority and how that the European lens varies differently than us, and how we can be able to advance those transit projects. And I'll take care of that in a second, Adriana. Thank you.
And I think we saw a few questions in the chat about whether this will be recorded. Yes, this will be recorded. It is currently being recorded now. So I think at some point later you will be given a link to the recording.
So we put the links in the chat for you guys to be able to sign up and give your voice. And in the meantime, I think we're about over by about a minute. I would like to thank everyone for attending today's webinar. We'll be sure to kind of be able to capture some of these questions and hopefully we'll have a follow-up or some kind of addendum. But in the meantime, thank you very much for joining us. Adriana, thank you very much. Marco, thank you very much for this wonderful presentation and the importance of what we can do here in the States. And so, the States, Canada, and beyond. So with that in mind, thank you all for attending. Have a wonderful evening, and we'll see you on the train. Thank you.
Thanks, everybody. Have a good night.